We have spent a lot of time talking about data collection and storage. Once you have collected the data, it's critical that you analyze it to gain a deeper understanding of your company, your clients, and your employees. That data has to be understandable, no matter what it is about. We will also go over some of Microsoft's Azure machine learning offerings so that you know what you can do with them on top of the data you're collecting, in the hopes of demystifying machine learning a little bit. As a matter of course, we'd like to know how to present the data. Most of the importance of data analysis lies in making it understandable to the end user so that they can derive maximum benefit and have the most actionable data at their fingertips. If you have worked with data analytics in your data center or SQL Server before, you might recognize a few of the services available inside Azure. A cloud-optimized data warehouse, SQL Data Warehouse makes use of the cloud's infrastructure to store data. The cloud data warehouse is going to be provisioned and we will get started. Servers, drives, and clustering don't need to be set up. We have just set up that data warehouse, and now we can take advantage of all the hardware and the increased speed and reliability it brings. Additional analysis services are available. You may recall working with something like this in SQL Server. Analysis services projects can be built using Visual Studio tools. Using the SQL Data Warehouse or other stores, you can manipulate the data and build models that make sense to your end users so that they can query and find the data they need to do their jobs. Data storage and analysis will be handled by these two services. Analyzing data as it is processed or ingested into the system is the goal of stream analytics, which takes a different approach. Real-time analysis of data. With time slices and chunks of telemetry data, you can analyze what's going on at a warehouse or system level as it's streamed through the system. Moreover, this is extremely well suited to handling large volumes of messages. This means that the system is designed to handle streaming and to process messages as they move through the system. Stream analytics follows this pattern. Data is ingested, analyzed in the stream, and then the results of the analysis are output. After that, you'll run the analysis on the data to produce some recommendations or decisions for your users within your application. If you're talking about analytics, chances are you'll hear about Azure HDInsight. This allows you to run a variety of open-source analytics tools such as Apache Spark, Hadoop, Hive, Storm, Kafka, or HBase in a cluster environment. In this case, you create a cluster, decide on the type of cluster it is, and then provision that. You can simply create a cluster and provision these tools using Microsoft's service, so you don't have to go out and set up servers, storage and networking and install these things and get them running. These are open source tools used for analytics on big data. When it comes to big data processing, it's more important to focus on getting to your application quickly and doing your data analytics than it is to build out infrastructure and use the cloud infrastructure to dynamically scale these clusters. Azure Databricks is a cloud-optimized implementation of the open-source concept. What you have is an Apache Spark service that has been optimized for the cloud, with a variety of tools to help you take advantage of that infrastructure. Apache Spark can be used in the cloud first because of its deep integration with many Azure services, such as Active Directory for identity management and role-based access control. It is important to note that while HDInsight allows you to create clusters of a wide variety of tools, the Databricks service is a focused offering that works with the people behind the open-source frameworks that it supports, making it the best experience possible.